Hi, and welcome to Gaming with EaselJS, an advanced canvas course on Tuts+. In our last lesson, we gave the hero a world of dangerous meteors to navigate. In this lesson, we're going to add to the functionality of the collision service and give our hero the ability to fire lasers to destroy the meteors. So let's get started. I've already added to our images folder a laser image PNG that we can use, and I have our grunt task running, and here is our source code. So create a new file. This is going to be our laser.js, our laser class, and we'll just give it the standard boilerplate we usually do. And we will initialize our laser by setting up its position, its name. We're also going to require that a rotation be passed. When our hero creates a new laser, when it fires a laser, we'll be passing our current rotation to the laser. The laser needs to travel along the direction that the hero was in when it was fired, so we need the rotation to be set. Here we set up the PNG, and here we add the laser to the collision service, this time with a collision type of point. Now our laser will also have a couple of constants. One is the bullet speed, the speed at which the laser travels, and the other is its lifetime, how long the laser lasts for. We can't have lasers just existing forever. It would be a massive memory drain, and it would make it a little too easy as well for the user. So when we set up our laser and its properties, we'll also give it a lifetime value. We'll have to increase this on each tick. And we need to set up the ratio at which it travels in the X and Y directions. To simulate the laser traveling in the direction that it's facing, we'll need to use trigonometry once again. We've already done these calculations before, so I'm just going to paste them in here. We basically set the speed in the X direction by doing math sine of the rotation, and the Y direction by doing math cos of the rotation in radians. Sets up the lifetime, the rotation, and the speed of our bullet. Next, we need an onTick function. So onTick is really quite simple. We just need to increase the lifetime and change the X and Y position based on the speed ratio we worked out before times the bullet speed, and the same with Y. Then if this .lifetime is ever greater than the bullet's lifetime constant, we should destroy the laser. Destroy is an instance method where we remove the laser from the collision service and from its parent display object. So we'll add that here. Basically, in terms of what our laser should do when it collides with something, well, it's really quite simple. The laser doesn't care who it collides with. As long as it's not the hero, it should destroy itself. Then what other things do when a laser collides with them is not really up to the laser to decide. So there we have our laser class. If we go into our hero class, we can require the laser first off and add a new property to our key actions. So if the fire 1 key is down, we want to set a property called firing to value true. We can set firing to false here. Then in our onTick handler, after we've processed actions, if our hero is firing, we can call fire weapon. In the fire weapon function, we will create a new laser. We'll pass it the X and Y position of our hero plus the rotation. Then to insert the laser into the display list, we need to get the position of the hero in the parent display list. So we'll use this.parent.getChildIndex this. Then we can call this.parent addChild at laser and pass the index. The reason being, we don't want the laser inserted above the hero, because that will just look weird. Let's not forget to add this comma here. To allow our lasers to interact with the other colliders, we'll need to make a change to our collision service. We now need to account for point types of collisions. Now the only thing it really changes is the distance. If we have a collision between a circle and a circle, the distance is the combined radiuses, or radii. Whereas if it's between a point and a circle, it will just be the radius of one circle or the other. And we can't have a collision between 2 points. In theory you could, but I'm not going to bother accounting for it because it's very, very unlikely. So since the distance is the only thing changing, that's the only thing we need to have inside this condition here. So I'm going to take the rest of this stuff out of the condition, and we're going to set our variable of distance to different things depending on what our types are. So if we have 2 circles, we add up the radii, whereas if self info.type equals point and other info.type equals circle, we're going to set the distance equal to the other info.options.radius. And conversely, if it's the other way around, we'll set variable distance into selfinfo.options.radius. Okay, to see if this works, we should go back to our meteor and add the condition else if other.name equals laser. We'll also want to destroy, but we can leave a comment that we may want to send out notification that we've been destroyed so that the game can update the score. Now we'll probably also want to set up a destroy method on the meteor. As you can see, we've already got a good case for setting up a bit of inheritance with our game objects. That's something you can do in your own time using lessons 4, 5 and 6 as a reference. So now you can see when we shoot the meteors, they also get destroyed. And when our hero crashes into them, he takes damage, but they still get destroyed. Now you may have noticed we have a fair bit of game logic starting to creep into our individual object classes. You may not want the hero class to know exactly how much damage it should take from each individual enemy or obstacle. There's definitely a case for creating some sort of rules module that sits outside of all that, where we can configure the various rules to cover all the various interactions between our game objects. I won't be covering that in this course, as it kind of comes down to an open-ended architectural decision. In the last episode of the course, however, I'll give you my idea of how we could go about organizing that logic. But that's all for this lesson. Check back in for the next lesson, where we'll be working out how we design our levels and how we store our level data. Ciao!